here at Imagination with the PowerVR area. And who are you?
Hi, my name is Alex Wojka, and I'm a senior marketing manager at Imagination Technologies. And thank you for coming. What we're showing here today are a number of demos running on our PowerVR Rogue architecture. I'm going to start with the first demo here. So we have here a side-by-side comparison between OpenGLES and Vulkan. So I'm going to switch to the OpenGLES version for a bit. So what we have here is a very complex scene where we have lots and lots of geometry. So we have a lot of characters being instanced in this scene. The problem with OpenGLES is that it puts a lot of demand on the CPU. So we're seeing the CPU being throttled by this very complex scene. So therefore, performance is there's a performance hit, so we're only seeing a few frames per second in this situation. Now, if I switch back to the Vulkan demo, essentially we have the same code. Vulkan supports multi-threading, so you can actually deploy all of your cores. In this case, we're running on a Google Nexus player, which has a quad-core Intel CPU with a PowerVR GPU. And also what Vulkan supports in addition to that is our PowerVR tile-based architecture. So it has been optimized for Vulkan from the start. Whereas OpenGL and OpenGLES, when they were introduced, which was about 2 decades ago, the hardware at that time was very different to what we have today. So traditionally, most of the architectures in the 1990s were immediate mode renderers, whereas now most of the architectures are tile-based renderers. So that's why Vulkan starts new with full optimization for Vulkan.
So you work hard with the Kronos group and
Exactly.
do a lot of optimizations over there?
Yes. So we announced at this event at CES, we announced a new partnership with Kronos, where we've basically ported the OpenVX framework for computer vision and optimized it for our PowerVR architecture. In addition to that, we've announced the PowerVR Series 7 XT Plus family, where in addition to supporting OpenVX, we've also added support for OpenCL 2.0. So last time we spoke, we were talking about how PowerVR was already compliant with OpenCL 1.2. Now we're showing support for OpenCL 2.0, which is the latest OpenCL standard.
What does that do, the new 2.0? Do you have some demos?
So we have a few demos that I can show you today. So here we have a Nokia tablet, an Android tablet, and a Dell Android tablet. And they're running OpenCL filters, face detect, and this is a special filter that we're using here. A technology that we have implemented, which developers could take advantage of, is called zero copy. So basically the ability to pass pointers between the CPU and the GPU. And previously, if you looked at the Android camera layer, you had to make multiple copies whenever you transfer data from the CPU to the GPU. But with this zero copy technology that we've implemented in the PowerVR architecture, you only have to pass pointers, so you reduce memory bandwidth a lot and you improve performance quite significantly.
So that's two big things happening with the Kronos group, is the Vulkan and the OpenCL.
OpenCL and OpenVX, yes.
And so you tightly working on that?
Yes. So that's computer vision is the next big thing that's happening in graphics at the moment. So we've had graphics and we've had lots of high resolution displays being driven, but now we're looking at computer vision and adding computer vision capabilities to the GPU.
And then what's going on with MIPS? Because that's what you're taking care of right now.
Yeah. So MIPS is seeing a lot of momentum at the moment. In fact, we had a press release talking about some of the design wins that we've seen. One particular area is the high-performance networking and high-performance compute. So this is an evaluation board from a company called Baikal Electronics. They're a Russian company. They've licensed our high-end P-class MIPS CPU. So it's a dual-core MIPS P-class CPU on this chip here. And they're using this board for home networking applications, but also for embedded computing. It's running Linux, so it's optimized for the Linux operating system. And they're going to come out with a sort of an enthusiast, hobbyist kind of board very shortly. Another dev board that we're showing here today is the MIPS CI40. So obviously We've had the MIPS CI20, which had a dual-core MIPS CPU and a PowerVR GPU, and this is what's driving this display here. But today we're showing the CI40, which is the next evolution in our Creator family. So this has a dual-core, dual-threaded MIPS CPU.
What does it mean, dual-threaded?
So the MIPS architecture was designed with the ability to support hardware multi-threading. So that means one physical core can have up to 4 physical threads, and Linux sees that as 4 virtual cores. So one physical core can be seen by the operating system as 4 actual CPUs. It's a similar technology to the hyper-threading that Intel offers in the high-end space.
So it feels to the OS kind of like a quad core?
Yes, exactly. So the Linux operating system, as far as it's concerned, it sees this dual-core, dual-threaded CPU as a quad-core processor from a software perspective. Another interesting gadget that I can show you today is this virtual gyroscope. So this company from Korea called Standing Egg have developed a virtual gyroscope by using the accelerometer function plus our MIPS CPU. We have very high performance DSP capabilities. So what they're taking is they're taking the outputs of the accelerometer, they're doing some filters, and basically they're simulating the behavior of a gyroscope. The advantage of that is they're able to reduce power, because gyroscopes tend to consume a lot of power. And you can see some applications here in wearables. So you can see this simulation here, and this person is detecting things like doing bicep curls and walking and doing push-ups. So it's all the information is being generated by this wearable virtual gyroscope that they've designed. Another area where MIPS is seeing a lot of success is in the embedded and IoT market. So Microchip is one of our leading partners. We also have MediaTek, which is here. So MediaTek have the Linkit system, and they also have a number of systems that have with MIPS, and a number of other systems that have been HomeKit certified. So HomeKit is the API for the smart home from Apple. We also have Qualcomm that uses MIPS. So their latest chipset has been running. They're showing here at the event running the Weave protocol from Google, and obviously Microchip, as I was mentioning, they're using, and this particular board, they're using our M class. So M class is our microcontroller class processor, MIPS processor. The unique thing about our M class is the ability to support hardware virtualization. So being able to run up to 7 virtual machines on the same microcontroller. And I'm going to show you a quick example of that here. So on this platform, which is an evaluation platform, we have the same CPU, and we're running Linux on one virtual machine, and then we're running this real-time operating system that controls the rotation of the motor in another virtual machine. One application is, for example, for wearables. You have your personal information, like your banking information or your personal health information, and you don't want those things to be all in the same container, because if someone gets in and has access, they will have access to all your personal information. So by splitting your banking details and your fitness details and other details in separate virtual machines, you're able to have better security and better privacy in your devices. Also, another application, for example, is automotive. So you have, for example, a microcontroller in your door car that is controlling, let's say, the car lock-on-lock feature, or also the window going up and down, and also your mirrors, the rotation of your mirrors. If someone gets through and hacks through your car, they can't unlock your car by going through, let's say, the mirror system. So by keeping those things separate and separate virtual machines, it provides better security for the automotive space.
All right, so there's a lot of MIPS being shipped, or what's the status right now?
So we're seeing more and more MIPS shipments. We've had a record year in terms of MIPS shipments. Another device I'd like to highlight to
Did you announce how many?
So we're shipping about 800 million right now, and we're growing. So we see a lot of design momentum behind MIPS, and you're going to see more of that in the near future. One other device that I want to show you, which is very new, it's this Pay Watch. So it's a wearable device that runs Android. It has a dual-core MIPS CPU.
It says Alibaba on the back.
Yes, it's the chipset comes from Ingenic, and it's a Chinese device, so the language is set in Chinese. But essentially, it's used for Alibaba. It's optimized for the Alibaba payment system. So in addition to being a wearable device, it's also used for micropayments in various Alibaba stores. And
I've seen those smartwatches. Smart glasses.
yes, so this is again another
Ingenic also?
Yes, Ingenic glass. So again, a dual-core MIPS CPU powering this, running
What's
Android.
the performance?
Performance is actually very good. The CPU is clocked at 1 gigahertz, so it's a dual-core CPU. Power consumption is very good, so I'm going to send you some information about the power consumption as well.
Is this something Ingenic or you or somebody else developed this?
So this is an OEM from China that licensed, obviously, the chipset from Ingenic.
Is it Top Sky? It might be.
It might be.
Okay.
I'll have to check on that. But I'll send you, they have a very nice product brochure where they list all the characteristics of the device.
Maybe it's the cool glass. And there's another
Yes.
one also. But
Yeah, so it's the same company, but slightly different form factor.
All right. Are they shipping yet?
Yes,
Or
yes,
is it
they're
just-
shipping. They're
they are
shipping right
shipping?
now in
They're shipping?
China. Yes, the same with
What's
the
kind
watches.
of the price?
It's very affordable. So I know the watch is at around $99, and I will check with the price of the glasses as well and come back to you.
Okay.
Another interesting demo that we're showing here today is our automotive demo. So, if you look at the PowerVR GPUs today, we are basically shipping very high-end GPUs into the automotive space, and that is because the automotive market needs high-performance GPUs to be able to drive the dashboard, to be able to drive the infotainment cluster, and also to be able to drive the screens in the back of your car. So Renesas and Texas Instruments, who are among the top 3 suppliers of automotive SoCs, they use high-end PowerVR GPUs. So in this particular device, the R-Car H3, we have a 6-cluster PowerVR GPU. It's one of our highest-end GPUs. And another feature that this GPU has is hardware virtualization. So the ability, again, to run multiple virtual machines and have each component, each display running in a separate virtual machine. So you don't want, if your kids are messing around with the screens in the back, you don't want them to take out your dashboard. So by running the dashboard and the infotainment cluster and the screens in separate virtual machines, if one of them falls over, or if one of them needs updating, or one of them needs restarting, you don't need to restart the whole system to do that. You can just control them individually.
So how soon a car is shipping with that? It takes a few years?
Usually it takes a few years, yes. So this is a platform that's just been released, and they're saying that the next generation of cars coming along are already looking at this platform to use it in their cars. So the cars that are right now on the roads, they use the R-Car H2, which is the previous generation of this platform. So that has a 4-cluster PowerVR GPU. But this is the new one with the...
What are you showing in this area here?
So what we have here are a number of devices that use our technologies. These are home entertainment devices. So we have some of the media players that are shipping right now with PowerVR, the Nexus player, the Apple TV, and the Amazon Fire TV, the new Amazon Fire TV. We're also showing some of our Cascade technology for wireless audio streaming. So what we have here are speakers that use our MIPS and our Sigma, or MIPS CPU and our Sigma Wi-Fi technology. And we have this additional technology we call Cascade that keeps these speakers tightly synchronized as we stream music over Wi-Fi. Another demo that we're showing here is the automotive demo. So we have essentially the Mobileye chip, which has a MIPS quad-core, quad-threaded CPU, a high-end CPU. And we're showing here how the Mobileye SoC does things like pedestrian detection, lane detection, incoming traffic detection. So Mobileye has about 90% of the ADAS market. They're a very successful company and one of our closest MIPS customers. We work very closely with them to ensure that they have what they need to build these SoCs.
So can you talk about some of the MIPS SoC makers? So there's Ingenic.
There's Cavium, there's Broadcom, Qualcomm, MediaTek, Mobileye, some of the exciting startups that we've mentioned, Baikal and Standing Egg. Microchip is very huge in the microcontroller space. So those are, let's say, some of our...
What is the Qualcomm doing with MIPS?
Qualcomm is using MIPS in their Atheros division and also in the Icarus division. So
for like the
Wi-Fi and home networking SoCs, yes. Another two customers that we have which use MIPS are Altair Semiconductor and Sequans Communications. They use MIPS for the 4G modems. So a lot of the 4G modems shipping today in tablets and also in the Chromebooks and some of the other devices, other connected devices, use MIPS-based SoCs.
All right. What are you showing here?
Yes, another interesting demo that I'd like to show you today is our PowerVR Raytracing GPU for the first time in silicon. So at CES, last year we talked about some of the demos that we had running on FPGA, but today we're actually able to show you the actual PowerVR Wizard GPU in silicon. So this is an ASIC that we've built, and we've put this chip on a PCI Express board. If you want to take a shot of the hardware. So we have here, we're doing a side-by-side comparison with NVIDIA. So we have a high-end NVIDIA GPU, that's the GTX 980 Ti, this system here. And then in this system here, we have our PCI, or tiny low-power PCI Express, so you see no fans, no cooling. They're both running the same workload. So we're basically doing real-time ray tracing, and we're showing that we have essentially 5 times the performance at 10 times lower power consumption. So if I quickly start...
So that's an NVIDIA with an Intel, right?
Yes.
Is it a GPU
yes.
running on an Intel system?
Yes. So basically you see this doing path tracing, and it's doing about, at a considerable rate, a few seconds for each pass. Now, if I switch over to our demo, which will take a bit. All right, so let me actually start them side by side so you can measure the performance yourself. So rendering image. All right, so what you're looking at is the performance, the number of how fast it's able to do these sample path tracing runs. So you can see that's up to about 5 now, but we're already at 23, 24, 25. So we're about 5 times faster. It's 6 here, it's 31 here. So we're about 5 times faster for the same workload than an NVIDIA desktop GPU. Another demo that we're showing here today is running on another PCI Express card. So we're basically showing you here.
So PCI Express on an Intel PC desktop?
Yeah, on an Intel PC desktop.
Does that mean you're entering the PC desktop GPU space?
So we're not in the business of selling chips, we're in the business of licensing. What we've built is a proof of concept so that our customers have the confidence to license this and use it. It scales from a mobile form factor, so what you're seeing there is built on 28 nanometers, but if a customer wants to take it into mobile, he can definitely, or that customer can definitely do that today. But then we can also scale into desktop and console. So if another customer wants to build a PCI Express card for consoles or desktop PCs, we can show that we have the performance to do that. So what you're seeing here is about 300 million rays per second in terms of the ray budget. But we can build you a configuration that scales into 2 or 3 gigaarrays per second. And that's what this demo is showing here. So this is running on a 4 PCI Express cards stacked together, which you can see here. I hope if it's not closed. Oh, it's closed. So basically, we're showing you that we can scale up to really high performance console class devices. So these demos are illustrating the fact that we can do real-time ray tracing today, but in a very low power and very area efficient manner.
What does the latest iPhone do with your GPU? Can they do this kind of stuff?
So this PowerVR Wizard architecture is right now we're showing it for the first time. So obviously this is the first time that it's appearing in silicon. We're hoping that we're engaging with customers right now, so we're hoping that soon we'll be able to announce some design wins. But so far, what we're showing is the Wizard architecture now exists in silicon and it's ready to be licensed.